Hey Group 4, we're going to be working on Vertex form today. You guys already mastered the standards for standard form and for factored form or intercept form. So today you're going to work on the third form, which is vertex form. Vertex form is y equals a parentheses x minus h parentheses squared plus k. With each form, there's one number that can tell you whether the parabola opens up or down. That number in vertex form is shown by A. If A is positive, then it's opening up. So if A is positive. And if A is negative, then it's going to be flipped down. So if A is negative. I'm now going to model how to tell based off of a vertex form quadratic if it's going to be flipped up or down. I'm going to read the formula first. Y equals parentheses x minus 2 squared plus 3. Well, let's see. There's no A there, but we all know that when nothing's there, we got to assume that it's 1. So I'm going to assume that this is 1. And that's not a negative 1. So I know that since A is positive, this is going to go up. All right, you guys try that with number 2, and I'll be back to check your work. Did you get that right? Let's check. Since y equals 3 times x plus 2 squared minus 5, A is our 3. 3 is positive 3, not negative. So the correct answer for that was A opens up. All right, guys. For grade 1 point, I want you to try this one. Make sure you get it right. Good job, guys. All right, let's talk about the axis of symmetry when looking at vertex form. The axis of symmetry can be found easy with vertex form because that value is h. So whatever h is in vertex form is your axis of symmetry. I'm going to model how to find the axis of symmetry from vertex form. Here I have vertex form y equals 2 times x minus 5 squared plus 3. Looking at my general form, I know my h is the second number, the number inside the parentheses. So 5 is my h. So if I want to know what my axis of symmetry is, then I'm going to label h as 5, and then 5 must be my axis of symmetry. Now notice that the general form is negative. So if you ever come across a number that is positive within the parentheses, that means that it's actually a negative number because 2 negatives makes it positive. So here we go, guys. I want you to try with number 5 to tell me if you think the axis of symmetry is shown in this formula. All right, let's check your work. Well, since you need h to tell you what your axis of symmetry is, I'm going to look within my parentheses. The issue with this one is, only thing inside our parentheses is x. So what exactly is our h? Well, when there's nothing there, can I assume it's 1 in this case? No, because there's nothing added to it. So we have to assume that this one is 0. So this is equivalent to x plus 0 squared, which means that our h is actually 0. So our axis of symmetry is actually 0 for this case. All right, guys, for 1 point worth of grade, try number 6 on your own. How'd you do? Great. Next, I'm going to model how to find the vertex of a parabola using vertex form. Now, this is super easy because it's called vertex form, of course. So the vertex is actually given to you. Here, you can see that vertex form is actually h comma k. In the general form of vertex form, h is within our parentheses and k is added on the outside. So I'm going to model how to find the h and the k from vertex form. I'm going to sit and label my vertex form here for number 7. This is H, this is K, and I'm going to write it as a coordinate point. 3, comma, 3. Now you may be asking why neither one of these are negatives. Let's take a look back at the general form. The general form tells you that this is a negative always. So I only make it a negative if it shows in the form as a positive. This one is positive always, so I will make it negative if it showed in my form as negative. As you can see, the signs in these are the same as the signs in the general form. So I kept the number the same as it kept them both positive. Alright guys, I want you to try the next one on your own. Did you get that right? Let's check this out. I have my H inside the parentheses as always, but there's nothing being added onto it. When there's nothing being added, we can assume that 0 is being added, which means our K is actually 0. Again, H is supposed to be negative so that it's positive. It's kind of backwards. So we're going to 6, comma, 0. Alright guys, I want you to try number 9 on your own for 1 point worth of grade. Hope you did okay with that. Let's just scroll up a little bit so we can work on graphic. Down just a little. There we go. Alright guys, to graph we need to put together all the skills that we just learned about vertex form. So, what we're going to do is first identify the axis of symmetry, which we already learned is H. Label your H. So the axis of symmetry is actually 2. Well, where's my vertex? In vertex form, my vertex is H and K. So I have my H and my K is 1, so my vertex is 2, comma, 1. I'm going to need one additional point to make my parabola. You see, I applied in my vertex where it is. So I'm going to choose one point on either side to find another value of y for my parabola. I'm going to try x equals 1. So I'm going to plug in y equals 1 instead of x because I'm substituting in 1 minus 2 squared plus 1. 1 minus 2 is negative 1 squared plus 1. Negative 1 squared is 1 plus 1, that's 2. So my next point is y equals 2, so x equals 1. So 1 comma 2 is my next point. I'm going to go to x equals 1, go up 2, and put that there. Remembering that my axis of symmetry is going right down the line for my vertex. If one point to the left of my vertex is at 2, then one point to the right of my vertex must also be at 2. So I'm going to put that point there as well. Because remember that our quadratics have to be, our parabolas, must be symmetric based off the axis of symmetry. So I'm going to connect those, and there you have it, one perfect parabola from the vertex form. All right, guys, on your paper, try number 11. All right, let's check your work. First, I'm going to find my axis of symmetry. Remember that that is H. And oh, look, this H is positive, which means that it's truly negative. So it's going to be negative 3. I'm going to go to x equals negative 3, 1, 2, 3, and mark my axis of symmetry. Just so I remember that that's there. What's my vertex? Well, that's H, comma, K. My K is 2. And it's supposed to be negative. It's supposed to be positive, so I'm going to keep it as positive 2. So that's negative 3, comma, 2. So on my negative 3 axis, I'm going to go up to 1, 2. All right, and then I'm going to choose one additional point, just like I did over here, to find for my axis. I'm going to choose -2. X equals -2. So I'm going to go ahead and plug in y equals 3 times -2 plus 3 squared plus 2. See, I just substituted in my x for the value that I want to find. So I got 3 times -2 plus 3 is 1 squared plus 2. Remember the common error I told you guys about. You square first and then you multiply. So I'm going to square 1 first. That's 1 times 3 plus 2. That's 3 plus 2. The answer is y equals 5. Y equals 5 when x equals 1. So that means my coordinate point is y 1, 5. I'm sorry, not x equals 1. X equals -2. Apologies. So at x equals -2, I'm going to go up to 5. 1, 2, 3, 4, 5. And again, I want to make my parabola symmetric. So if I went 1 right and I'm at 5, then if I go 1 to the left, I also need to be at 5. So I'm going to go back to my axis of symmetry, go 1 point to the left, and I'm going to put another dot. I'm going to make my parabola, and that's what you should have graphed. All right, for 1 point worth of credit, guys, try this one. This is going to be the last problem of the day. All right, I hope you got that right. If you are confident in your work, great. Your exit ticket is on your packet. Go ahead.